Start. There we go. Hey everyone, I'm going to talk on this video about the various functions of the respiratory system. And again, this kind of plays into the last video I made, to where for me it helps that I have a solid understanding of a system so I can apply that understanding to various circumstances. Because in your line of work, I think a solid understanding of what you're supposed to do is better than having to get an exact answer. Right? If you understand something, you can work within that understanding. It can help you a whole lot more. At least that's what I've found in my career. So let's look at these various functions. First function is, and we talked about this other one, is to ventilate. Ventilation of the lungs, right? And that's just to move air in and out. And obviously that's going to help us pick up oxygen and pick up oxygen and get rid of carbon dioxide. So ventilating the lungs is a really big primary process. Another process is for respiration. And that's gas exchange. And if you see this word exchange, it means that we're exchanging carbon dioxide for oxygen. So gas exchange. And the respiratory system provides an area, a large area. Well, actually, large areas for this to happen, primarily in the alveoli and between the alveoli and the alveolar capillaries. And then down at the cells. And this is, right, you have your alveoli. Horrible drawing. But now these alveoli are absolutely covered in a network of capillaries. So it's not just like one little capillary right over there. It's a whole bunch of capillaries. That's how important gas exchange is. And this happens, this is external respiration and internal respiration, or pulmonary, you could say pulmonary, and that just means lungs or cellular, right? It's kind of where it's happening. Or, external means it's with the environment or the atmosphere and us, and internal is obviously within our body. So that's another big process. You can stay with purple. I like the color purple. 3. The major function is protection. The system is designed to protect these areas, right? We need to protect, especially in our alveoli, in our lungs. We need to protect those very delicate alveoli from anything that could harm them. And what we mean, we're going to protect them from debris. Now, why would that be important? We got to filter all this debris out. You figure in the air. Gosh, I can't tell you, every week I have to sweep and dust my apartment. We can't see the debris that's just floating around in the air. It's too small. But if you think, and I posted a video of showing kind of the extensive network of our bronchioles. Those are little tiny tree extensions off the bronchus, and then the alveoli. They're itty bitty, and so if you figure even a small dust particle could potentially obstruct those airways and prevent gas exchange. So we can't have any debris going down there. So we got to filter. So it protects it. So filtration, and it traps it too. We're going to talk about that in a minute. Okay, so from debris, from pathogens. That's virus and bacteria, right? Virus, bacteria, fungus, right? And then from temperature, from dehydration, let's say dehydration. Dehydration. All right, and then temperature extremes. too hot, too cold, we can't have it. If you get hot air, one of the biggest dangers of a fire scene, not necessarily people just getting burned, but inhaling the toxic fumes, but also the superheated air that's very dangerous for us. Same thing with really cold air. We don't like that. So your body's job is to, or the job of the respiratory system is to make that air nice and moist so we don't dry out our lungs, and keep the temperature at body temp. So when you inhale cold air, your body's job is to heat that and humidify it. Very important. When people get put on long-term home oxygen, it's usually through the nasal cannula, and they have to have a reservoir of water, so you push that air through the water so it humidifies that air so it doesn't dry out their nostrils, dry out their nose. So protection is a very big part of our respiratory system. Oh, we got space up here. I can go right next to it. Let's different colors so we can see it. All right, so 4. This is going to be our senses. Sense of smell, called olfactory. Olfactory. And then our sense of speech. You could also probably put in their taste, right? That's more like food, but you can taste stuff on the air. So our sense is very important. So let's talk a little bit about how these structures accomplish these tasks, right? Now, the primary area through which we breathe is our nose, our schnoz. And here's my best drawing. There's his lips. We got a chin. I don't know what this is. Sorry about that. And then our neck and our big old head. This guy got dropped on his head, apparently. It's a little flat. We'll extend that down. And here's our Adam's apple, our larynx, right? All right, so our primary source of breathing, our primary entrance is through, you know what, I'm going to add another layer to this. So I'm not drawing on that layer. Add another layer. We're going to draw on that layer. So I'm not going to ruin my coloring book here. So our nose is our primary entrance point for how we breathe. We're supposed to breathe through our nose. This first part, the squishy front part, is called the vestibule. And you've probably heard that if you ever camp, the vestibule. Now, the vestibule contains a whole bunch of coarse hairs, and you can see that on old timers. They get the big old hairy mess, poking out there. Well, those hairs are to filter the air coming in. And what the airway has inside, I'm going to go back to blue, is what we call our, here we go, we're going to draw the floor. So this is called the hard palate, right? Soft palate's back there too. Here's the hard palate. It's essentially the roof of your mouth, right? That's the hard palate. And then inside of our nose, inside of our nasal cavity, and that's this whole big cavity up here in the front, we have what are called conchae. And in Latin, when I looked that up, it said a shell-shaped structure. And you got 3 of them. You got a superior, that's up top, middle, and inferior. Right? And these concha and this cavity serves a very important purpose. First and foremost, all of the cells in this area are mucous membranes, which means they secrete a mucus. So this is lined with mucous membranes. And not only do they have mucous membranes on them, this is our mucous membrane layer, but those mucous membranes those cells also have cilia. I'm not going to draw hairs on everything, but you got a whole bunch of cilia. And those are the hair-like structures that project out. And so you've got your mucosa, and that obviously produces mucus. And you got your cilia, right? And the whole purpose of this is to filter and trap air, or filter and trap particles in the air. And from what I've read, it can trap things, particles up to greater than or equal to about 10 micrometers. So pretty decent sized chunks for what we're, for where they're supposed to go. Oh, I should probably get that. There we go. And so we got all these, so all this secretes mucus, hence we get boogers, and the cilia. So air comes in, and it comes in contact with these surfaces. And not only, so look at how teeny tiny this space is in between these concha. Well, that serves a purpose too. And these areas, these spaces, are called, let me make sure I'm saying it right, the meatuses. So that area is called and all that means is a narrow passageway. And you got 3 of them, right? Look at that. And so it's very thin. There's not much space here. And so what that causes is as the air comes in, it causes turbulence. Anytime you narrow a passageway, and we deal with this when we intubate people, is it's not if you have a tube, right, and we tube someone, we're not pushing air through the exterior lumen, that's a lumen, it's through the interior lumen, right? So you're like, oh, that's a nicely sized tube. No, except it's the middle lumen that we need to be focused on. And so the more narrow it is, the more turbulence you're going to get. And this turbulence inside the nasal cavity makes this air turn and swirl. And so it forces that air to come in contact with the mucous membranes and the cilia so it can trap those particles and filter it. Not only is it going to trap those particles, that cilia, once it's trapped, that cilia is going to direct those particles back to your pharynx. And that leads down into the esophagus. So it can go into your stomach, and those pathogens and those particles can get exposed to the stomach acid and get destroyed. It's really important. Another aspect of the turbinates, and this is all called turbinates as well, but concha is what I've decided to call them, is that they're highly vascular. You got a whole big network of blood vessels all over, and we can see that when we get so many nosebleeds. A lot of people. This is nosebleed time of the year now too, because the air starts getting really dry, and that makes the skin, the really thin mucous membranes, very susceptible to rupture. So we go on a lot of nosebleeds, and some incumbent nosebleeds are nasty business. And so we've got all these blood vessels here, and what's that going to do? It's going to serve the purpose of heating the air that's coming in, because it comes in contact. So the blood carries our body heat away from us and to exposed surfaces, and it can release that body heat to heat the air. So by the time that air gets down into your lungs, it's essentially at room temperature. And not only does it heat the air, but what also happens is the mucus that's released by the mucous membranes contains water. And some of that water gets evaporated by the heat from our body, and it humidifies the air as well. So it serves so many purposes. The nose is so important. And that's why we're designed and why we primarily breathe through our nose, so we can have those many protections from the air that we're going to breathe in. Now, when people start breathing through their mouths, this happens at like 2 in the morning when you're working a 16-hour shift, we turn into mouth breathers, you kind of lose a whole bunch of those protections. Right? Now, you still have your tongue, obviously, and your tongue is nice and anchored to the floor of your mouth, to the mandible. The way I remember mandible is, to me, it sounds like nibble. So I remembered that's the part of the jaw. So your maxilla is up here. Maxilla and mandible. So mandible to me sounds like nibble. So I always remembered that on tests. Which one moves? The nibbly one. So you got your tongue. Your tongue is going to protect you from, I guess, choking on stuff, right? You have your gag reflex. Now let's look at the pharynx. So here's your pharynx. Your pharynx is your throat. So you have your oropharynx. Oro means oral, right? Nasopharynx means nose, throat. And then your hypo or laryngopharynx. And hypo means below, right? So we get into the larynx area. And here we've got our epiglottis, that big flap. And we're going to separate our trachea from our esophagus. Now, our esophagus is collapsible, right? So when it's not in use, it's not open, right? And here's our esophagus. When it's not in use, it's not open. It's collapsible, but our trachea is open. Make that blue again. So here's our trachea. Whoop. All right, and we got a couple protections in our trachea. We're going to give this guy a shirt. A couple protections. We have our epiglottis, and when we swallow, the muscle contractions force this epiglottis to cover that opening, because we don't want food going into our trachea and down into our lungs. We want food going into our esophagus and into our stomach, right? So not only does our epiglottis come down and cover our esophageal opening, but when we swallow, the muscles actually push this lower part up to where it kind of meets that, so they can overlap a bit. So it really provides good protection from us swallowing stuff that we're not supposed to swallow. Or I'm sorry, inhaling stuff that we're not supposed to inhale, that's not supposed to go into our lungs. Really, really important. And also the cilia, so this is still mucous membranes down here, and still covered in cilia, and those cilia actually push, let's go back to my pen. Those cilia actually push trapped particles upwards, so we can swallow those particles as well. So that's why, you wake up in the morning, you give a good cough or a hack, and that's pushing that gunk up and out and trying to get you to swallow it or spit it out. Let's look at the rings of the trachea real quick. Let's look at the rings of the trachea. Let's do purple. So you got the trachea, right? And here we go. We start getting our rings. Now the trachea's actually got no rings back here between it, so food particles can move and squish our trachea. But we've got these rings that support the structure of our trachea. Now, why on earth would our trachea need rings to it? Well, okay, yeah, obviously, let's say someone were to throat punch us, right? Here's a fist. Yeah. Right? So in case we get throat punched, yeah, that's important. But look at what happens when we breathe. When we breathe, we create a negative pressure inside of our respiratory system. And if we didn't have these rings, that negative pressure would cause our trachea to collapse inward if we didn't have those rings supporting the structure. So our active breathing would cause us to collapse our airway. And we can't have that. The negative pressure that we generate is so powerful that we would close our airway down. So we've evolved to have tracheal rings, hard cartilage that keeps that open from collapsing. And that cartilage extends down into your bronchioles. Not all the way down to your respiratory bronchioles, but far down and even into the lung tissue. Because again, we're generating such negative pressure. So that's kind of more explanation of the purpose of some of these structures. Oh, and obviously, here we go. My apologies, I totally forgot. We have here's the epiglottis, and we have the glottic opening. And that's where you have your vocal cords. So here are vocal cords, and this is in the larynx. And your glottic opening. This is the most narrow portion of your upper airway, so easily occluded by food. And this is obviously for speech production, right? And I got about one more minute I'm going to take. Here's something to remember. These are all mucous membrane cells that line our airway. All of these cells can swell. All of them can become inflamed and infected. And one thing that we see sometimes is epiglottitis. Itis is inflammation. Inflammation. And so any of these can get inflamed. I had some guy with uveitis. Uvula is the hangy ball at the back of your throat. And his hangy ball was about the size of an avocado pit. Remember that, you had a hard time breathing. So just keep that in mind. Any of these things can become inflamed and make us feel like we can't breathe too well. Epiglottitis is a very serious condition that we sometimes see. That's it for this video. I hope it helped. I hope it kind of explains stuff, and I'll see you in the next one.